Hello everyone. Welcome to the second AIA Live event. We are 18 months into the pandemic, and it is with great hope that this half-day event will provide a fresh perspective on finding purpose despite the challenging times, but by doing it, maintaining our physical and mental well-being. My name is Dr. Myra, AIA Group Medical Director, and I am thrilled to be hosting the AIA Live segment on genomics, future-proofing for a healthier, longer, better life. As we look to the future, our commitment to creating a healthier Asia in our communities is reinforced by our brand purpose to help millions of people live healthier, longer, better lives. And the simplest way to start is to understand our genetic or genomic makeup and its implications on our health and well-being. What I'd like to do today is to have a conversation with our genomics advisor, Professor Robert Green, with the hope that this session will empower you with some basic information, inspire and motivate you to learn and understand the connection of genomics or genetics to how we get to a healthier, longer, better life. Please join me in giving a warm welcome to Professor Robert Green. Robert is a professor of genetic medicine at Harvard Medical School and a physician scientist who directs the Genomes to People research program at Brigham and Women's Hospital in the Broad Institute. Professor Robert is internationally recognized for his research and policy effort in accelerating the implementation of genomic medicine. Robert, welcome to the event, and it's wonderful to have you join us.
Thank you so much, Dr. Myra. Delighted to be here.
So let's dive straight into genomics. Now we know that genomics is an important and valuable tool to be aware of, but it's a word that many may not understand. Can you help me deconstruct genomics for the everyday person? What is genomics, and why is it so important for us to understand?
Dr. Myra, genomics is a word we use to talk about the entire system of the DNA within our bodies, within each cell of our bodies, that creates the building blocks for life. Genomics refers to all of the genes, all 20,000 of the genes in every cell in our body, and it refers to our knowledge that we're gradually creating, developing, improving, and refining about what each one of those genes does, how it can be broken, what are the disease implications, and eventually, how do we treat and prevent the diseases that plague all of humanity.
Genomics has always been a very difficult word to understand and the science behind it, but you've managed to kind of encapsulate that into a simple sentence. Prof, you know how genomics in the past, we've learned that by understanding the genomics, we are able to understand certain diagnoses. But today we are using genomics information to understand prognosis and treatment. Could you just very quickly talk through those aspects?
That's right. The genome is the full extent of all the DNA, and there are about 20,000 genes that we now know constitute the genome in the human body. And we've sort of learned that about 5,000 to 8,000 of those genes are strongly associated with human disease. And we're gradually untangling the message in those genes to understand if you or me or any given person is at risk for a particular disease. So for example, we know that if you have a variation, a pathogenic variation, or what we used to call a mutation in a gene like BRCA1, you're much more likely to have breast and ovarian cancer at some point in your life. And that gives you a real edge. That kind of information is power because it means you can be more alert to the possibility of that cancer. You can surveil yourself for that cancer. You can avoid that cancer in the future or catch it earlier.
Does ancestry play a role in our genetic composition?
Well, so much of healthcare and disease depends on non-genetic factors, what we eat, whether we exercise, and so forth. But underneath all that is the importance of the genes that you have in your body. The good news is that as human beings, we're 99.999% exactly identical. But it is important to recognize that some DNA changes are different within ancestry groups, and therefore, particularly the combinations of genetic markers within each ancestry group need to be analyzed specifically. Now, Dr. Myra, what this means for all of us is that genetic knowledge is going to be useful and valuable, whether it's generated in persons of European ancestry or persons of Asian ancestry, but it's going to be even more valuable if we specifically build up databases of genetic information within each specific ancestry group.
So, because I'm Asian and the propensity of developing certain non-communicable diseases like diabetes or hypertension, because I have this genetic composition, am I a lot more prone to developing some of these non-communicable diseases versus someone who's Caucasian or someone who's American, or, if you could just explain a little bit on that.
Yeah, remember that most disease-associated mutations and markers are passed down from generation to generation to generation. And so when ancestry groups have lived in a single location for a long time, many centuries, there are certain DNA changes that have sort of passed down and certain combinations of DNA changes that are inherent to that ancestry group. Now, sometimes it means that the ancestry group as a whole is more likely to have diabetes or some other condition than another ancestry group as a whole. But more often it means that these conditions, heart disease, type 2 diabetes, multiple sclerosis, atrial fibrillation, various forms of common cancers, it more likely means that they are distributed throughout the population in different ways. But more importantly, if you're going to try to understand the genetic markers that cause, heart disease, they're going to be a slightly different set of genetic markers among people of Asian background and ancestry than they're going to be among people of European ancestry. So it really speaks to the need for a database or multiple databases around the world. We understand that all this information has got to stay private. It also, for maximum utility, needs to be shared around the world. And there are ways to do that and maintain privacy as well.
Well, I'm going to shift gears a little bit now that we are in the pandemic. It's been 18 months since the pandemic. And I mean, we all know that scientists now understand a little bit better of the coronavirus and, have collected quite a number of data points. What have we learned about genomics or our genetics, and in reference to one's vulnerability to COVID-19?
Well, of course, the biggest factors in vulnerability to COVID-19 are non-genetic factors. They are obesity, they are underlying diseases that make you vulnerable, immune problems. All of those conditions sort of in the background are the things that really, really cause vulnerability to COVID-19 severity, mortality, and so forth. But there are also genetic markers that an international consortium of groups, of which I was a member, have put together. And they found that certain genetic markers in the genome are responsible or are associated with more severe outcomes like hospitalization and death. These are not sort of solving the COVID problem, these genetic markers, but they are giving scientists clues to try to find the kinds of treatments that will be more effective for both immunization and treatment down the road.
It's very challenging times. And I'd really like to understand from you on a personal level, how do you stay so positive, so upbeat, and, just having a great outlook on life?
Well, thanks. I guess I'm really supported by my family and my colleagues and the entire field of genomics, which every single day excites me about the future for the benefit for humanity. You know, we've been talking about the human genome now for about 20 years. And from the very beginning, we have said there's going to be a day when every single human being has access to their own genome. Their doctors have access to their genome, and it is integrated with their day-to-day health care. And that is a dream that I think we are finally getting close to. There are new treatments for rare genetic diseases that every baby should be exposed to if they happen to carry that genetic risk. There are medications that work better in people with certain types of genetic markers than in others. There are reproductive advantages to knowing if you and your partner carry a DNA change that's going to result in a devastated baby, and reproductive technologies to avoid that. So, whether you're talking about the beginning of life, you're talking about reproductive years, or you're talking about midlife and avoiding cancers and heart disease, genomics is one of the advances that's changing the world, and it's going to make us all healthier. And I'm just thrilled to be part of that movement, that scientific initiative, that progress, and that promise at this point in our history.
Well, a lot of great information, Robert. And really, a quick lesson on Genomics 101 made easy. I suppose it's quite clear that we will have to embrace the notion that genomics is a positive and not a strange or scary thing, and that it is very helpful science for us to understand and help inform our decisions about our health and well-being. As a final thought, and in line with our topic today of future proving for healthier, longer, better lives, what message would you like to leave with our audience?
Well, Dr. Myra, I think I would remind people that genomics ultimately is going to be part of their day-to-day healthcare. I think that the future depends on us accepting genomics as a day-to-day part of our healthcare and generally embrace this progress. Someday we're going to look back on this and say, why did we take so long to start working with our genomes in our healthcare? And I think we'll be very, very glad for the progress we're seeing today.
Thank you, Professor Robert, for your inspiring insights and valuable time. Thank you, and a big shout out to our fabulous audience for joining us on AIA Live today. I hope this session has educated, inspired, and motivated you in some way to better appreciate the fascinating world of genomics. Thank you, everyone.